Hey, Mr. Keller, doing test corrections for test number 6. So, number 1. Hit. So, number 1, we are trying to find the velocity of the car at 4 seconds, so I use the equation force delta t equals m delta v. So that's impulse, and so we're given that, or you find that the force times delta t is 6, which is the area under the graph, equals m delta v, and you're given m, which is 2, so it's 6 equals 2. 6 equals 2 delta v, so delta v equals 3, but then you have to find what delta v actually is, which is vf minus vi, which is the final velocity, initial velocity. So you know that 3 equals final velocity minus the initial velocity, which is negative 6, so then it ends up being negative 3, which is then c. Okay, and then number 2, gotta make sure this is still recording. Yep. Okay, cool. Okay, number 2, it should be right, left, stationary, and that's because the person standing on the board is moving right, so they're providing the only force on the wooden plank, which is the friction force, so it's actually moving it left, and then but the person is moving more to the right, but it's not as big, so the actual center of mass isn't moving, so it's right, left, and then stays constant. Okay, and then we move on to number 5. And number 5, you're essentially doing the same thing as the first one, so you're doing f delta t equals m delta v, and so you're given m and delta v, and you're trying to solve for force, but you're not given the time, so it can't be determined, so it's D. Okay, and then we move on to open response question number 1. Start with 11b, and so you're trying to find the horizontal velocity of the ball right after. So you're given what the impulse is from part A, which is the area under the graph, which is 16. So it's 16 equals m delta v, and delta v is still final minus initial. So it's 16 equals 0.4 kilograms, and then vf minus vi. But you know the initial velocity is 0 because the ball isn't moving right away. It has to wait till it gets hit. So it's actually at 0. So it's just 0.4 and then vf. And so then, it's 4. So then you just do 16 divided by 4, which is 4. So the final velocity is 4. Then you move on to 11c, which you use conservation of momentum. Okay. Then you move on to part C, which is conservation of momentum. So it's m1v1, or if you're really thinking about it, it's m1c1 v1c1, or vc. I don't know. So anyway, the ball isn't moving, so that's just 0, so it ends up just being 0.4 and 24 because the block's moving at 24 meters per second, but then it equals 0.4, and then you're trying to solve for the final velocity of the cube. And so after you basically do all this math, you get 9.6 equals 0.4 vf plus 16, and you got 4 times 4 because the velocity of the ball is 4 meters per second and it weighs 4, so it's 16. So you get 9.6 minus 16, which is negative 6.4. Then you divide that by 0.4, which is negative 16, and it's not actually negative, it's just 16 moving to the left. And then for part D, it's determine the kinetic energy that's dissipated. So you're doing just 1/2 mv squared, which so you're doing 1/2 mv squared for both of them. So the mass of the ball is 4 and the velocity is 16. So basically, after you get them all out, the energy of the ball is, of the system at first, is 115.2, but then the energy at the end is 83.2. So the energy lost is 32 joules. And then for part E, you're trying to find the distance between the 2 points of impact of the objects. So you have to put it into a kinematics table. So you're trying to find delta S, which is like the distance traveled. And so you're given the initial velocity, and then you have to solve for time. So you have to go into the y dimension and use acceleration, which is 9.8, and the distance traveled in the y dimension, which is 1.5. And so then you use an equation and you get 0.55 seconds, and then obviously negative 16 times 0.55 equals 8.8. And then you just use the same amount of time for the ball because they're both in the air for the same amount of time, same acceleration due to gravity. So then you do 4 times 0.55, which is 2.2. And so you'd think the difference apart would be 11 meters, but since the table is actually 3 meters, you have to add another 3 meters, and you get 14. Sterling, please do it again. Nice. Okay. Okay, and then move on to 12. So 12. So 12B, you're trying to find the change in momentum, which is F delta T, because that's the easiest. And so you're finding the area, and so the area under it is 0.3 kilograms times meters per second, so it's just 0.3. And then 12C, you have to use that, so you're trying to find the mass. So for this, I did force delta T equals m delta V, because you're given delta V from part 1, or no, just from the graph. So then it's 0.3 equals negative 0.2, so you actually end up getting 1.5 is the mass, so it's 1.5 kilograms. And then for the last one, you're trying to find the energy lost, which is 1/2 of 1.5 0.11 squared. So you're just doing 1/2 mv squared for the first part compared to the second part, and so you get 0.0091 equals 0.0061, which actually isn't that, so it's lost 0.003 joules of energy.